All right, page 2. So here's another awesome photo of 3 cars when they were testing them. So this one in the front here is the Audi, that's the red one. The blue one over on the left-hand side, that is the Mercedes AMG. Then in the back is the BMW. So another view of these 3 cars. We're going to determine the average rate of change of these in terms of their speed. So how would you use, or how would they use the average rate of change to determine which is the fastest car? Well, in order to do that, average rate of change is how much the y variable is changing. So remember back when we talked about slope, we originally talked about the change in y over the change in x, right? So notice that the average rate of change is exactly what we used to do when we were trying to figure out the slope of a line, right? Delta y. Remember, the symbol delta means change in math. So we're talking about how much the y variable is changing relative to how much the x variable is changing, or delta x. Okay, those are really bad triangles, but you get what I'm talking about. Delta y and delta x. And when we're trying to figure out how they relate to each other, we're looking at a ratio, and ratios are always fractions. So there's a little fraction symbol here. I'm going to put that all together. What I'm talking about is the average rate of change, okay, or the slope of the graph. Slope, average rate of change, exact same thing, okay? So the slope, remember, the average rate of change is delta y, or the change in y's, over the change in x. Okay, so how much the y's are changing and how much the x's are changing. Now, in order to figure that out, okay, we need some data points. So let's take a look at the graph. So I've taken these points straight from the article, okay, and I've sort of made it 8th grade math friendly. So in reality, these cars are not going at rates that are straight lines. It should be a curve, okay, but for our purposes in 8th grade math, we deal with linear graphs, right, the most. Okay, so we deal with line graphs. So I simplified it a little bit, okay, which isn't going to change the answer, but it is going to make it a little bit easier for us. So I've taken these data points and I've sort of shown, so here is our 3 cars, the red one, the blue one, and I made the BMW purple, even though originally it was gray, just because it's easier to see purple on the graph. So we need data points in order to do this formula here. This is our average rate of change formula and our slope formula. Remember, average rate of change and slope are the exact same thing. So we need to figure out some y values and some x values in order to determine what the change in y and the change in x are. So let's start pulling some y values, some xy values. So this says, how long did it take each car to get to 60 miles per hour? So we're talking about 60 miles per hour, which is right here. And these are the data points we're looking at, and we're trying to figure out how long did it take each of these cars to get there. So we're going to have to use our thinking caps a little bit because they aren't exact and they're not labeled. So we're going to have to do the best we can with that to determine what our x and, well, we know what our y values are. They're all 60, but our x values are going to be kind of all over the place. So let's start with Audi. That's what they're asking first. So Audi is the red. The red dot looks like right here. If I drew a straight line down, okay, I'll draw a straight line down from that point. So it looks like it's right about there. So it's in between 2.5 and this middle line would be 2.75, because halfway between 2.5 and 3.0 would be 2.75. So it's in between. It's a little bit closer to this line than this line. So we're going to go with 2.7. Okay. And again, this is an estimate, but we're estimating everything, so that's okay. Okay. So it took 2.7 seconds to get to 60 miles per hour. So this point on the graph was 2.7. 60. And this is important because we're going to use this point to determine what the average rate of change is between 60 miles per hour and 100, because that's really what we want to know. Which car sped up the fastest or accelerated? You probably heard that word accelerated. That means the rate that they are speeding up. So which car accelerated the most from 60 miles per hour to 100, which means they're really going fast, right? Like 60 to 100. These are dangerous speeds. So we want to know who gets to 100 the fastest, basically, okay, from 60. So Here we are. That was 2.7 for the Audi. Let's look at the Mercedes. Mercedes was the blue one. All right, so blue one is right here. And if we just take a straight line down, it looks like that one's an easy one, 3.0. Okay, so 3.0 for the Mercedes. And we'll put seconds after it. Let me make that white so you can actually, white might now work. Try black. There you go. You see that better. All right, and let's make that into a point. So 3.0, and again, the output is 60. So it took 3 seconds for it to get to 60. So it took a little bit longer, right? Does that mean it's the slower car? Well, we're trying to determine who was the faster car between 60 and 100, because that's really where the speeds are happening, right? Even a Toyota Camry can get pretty quickly from 0 to 60, but it's really about from 60 to 100. Can you accelerate really quick? That's kind of what we're trying to figure out. That's what Car and Driver was trying to figure out in their magazine. So we are doing the same thing they're doing. So last one, BMW, that's the purple. And let's figure out where they're at. So that's right here, which is a little bit past 2.5. So we'll say 2.6. All right, just make it easy. We'll say 2.6. Okay, again, we're just making estimates, so it doesn't have to be perfect, as long as obviously it makes sense in terms of the other one. So obviously this one, 2.6, because it was closer to the 0 than this one. We made 2.7 because it was further away. Okay. Yeah. So that's that. Let's make it into a point. So that's 2.6 and 60. Okay. Next page, we're going to determine how long it took them to get to 100, speed 100, and then that's going to help us with our rate of change formula. So I'll see you in the next video.